Hello everyone, my name is Lam Nguyen. Today we'll talk about minimizing residual stress in direct mirror laser sintering via two-pass plane. First of all, we'll talk about the background of my project. The application of the DMLS in the manufacturing of the functional parts has become increasingly reliable. The technology entails the use of the high-powered laser beam, which may associate with error. However, the errors made during the design process can lead to residual stress, which may cut for the different approach. Some errors include mismatching feature, misalignment within feature, and incorrect material thickness. Improved two-pass may cause residual stress. Two-pass plane is an optimization technique that's why a solution. Highlight from relative work. The FAA metals considered in the preliminary simulation are carbon steel and aluminum. Low carbon steel and aluminum alloy stress-strength relationship are to use in FAA. The procedures involve calculating the stress and strain at its point in a 3D model of the materials with FAA software. The stress and strain can be compared to the result obtained from the experiment conducted using the test apparatus such as tensor tester or uniaxial compression machine. The table shows the different type of the 3D DMLS printer that codes materials loss number, manufacturer, and minimum stacking fit for each. It is important to note that each variable in DMLS printer play a significant role in helping achieve the objective of producing residual stress. The 3D printer serves as a sample for testing the different outcome of the minimization process through the two-pass planning. The objective of this project is determine how residual stress can be minimal. In the DMLS, using ANSYS to build up a CAS model. The process of create a CAS model to two-pass plan in use the data from the CAS program to create a representation of the project. The ANSYS software can be used to simulate the process of the DMLS from the start of the process to the end, including materials property and boundary condition, temperature, pressure, and humidity control. Risk and contingency. ANSYS software benefits users by uploading them to solve the problem safely and efficiently. However, there are a few aspects associated with ANSYS software, including the first navigate FSE. That it can be difficult to navigate through the software. The navigate an ANSYS model. Users must first set up their model and then insert the data they wish to analyze into the model. The process can be challenging for the beginner and expert who may not have previously spent much time using ANSYS. Major deliverable. The project has 4 major deliverables and it will have significance in achieving the project objective. The deliverables include the preparation of the CAS of geometry for simulation and testing, source code model for optimizing laser sintering two-pass, system level flow diagram, and ANSYS model. The deliverable effectively determine not only the amount of residual stress can be utilized, but also available techniques. For analyzing the residual stress, the thermomechanical models will consider significant. The thermomechanical model can help analyze residual stress by determining the temperatures and pressure, and which material will factor. It does this by determining the stress and materials will be experienced as its change temperature or pressure. These models will helpful and used on the DMLS. Besides, the models can utilize fresh application to determine the amount of residual stress applicable. Evaluation metric. The final result of this project is development of the two-pass plan in algorithm for the DMLS. Algorithm take into account both material property and process condition of the DMLS, as well as the geometry of the parts being created by DMLS. Algorithm can predict how long it takes for a tool to reach its final position and how much force it will need to apply to get there. This allows designer to minimize residual stress in their research. Methodology. The project impressed on the approach. That's considered the application of the ANSYS, which helps build a CAS model. Engineering and theoretical model are significant for understanding how to simulate printing a CAS model by using a DMLS printer with a default setup. This model is associated with various vital routines, which helps in validate optimization process and parameter such as a thermomechanical model, understanding how to simulate printing CAS model using a DMLS printer with a default setup, minimize residual stress in DMLS. Some routines are auto-dissolved compensation, phase transformation tracking, microstructure prediction, and thermal history prediction. This study investigates how to minimize residual stress in DMLS part using two-pass planning. Two-pass planning is optimization technique. That's why a solution for the producing parts with minimal residual stress based on the current two-pass design and manufacturing condition. Improper two-pass may cause residual stress in DMLS part due to neglect the familiarity with the material. To address this issue, the process proposed methods for minimizing residual stress using two-pass planning. Resource needed. There are several resources available if using ANSYS model. First, they need to use ANSYS software itself due to its effectiveness in performing an effective simulation. The software is used to create model and perform simulation, and the software can be downloaded from a website. There is this for the CAS of geometry for simulation and testing. This geometry can be utilized in engineering to establish the necessary outcome as it pertains to the stress of the DMLS. Preliminary work. The work focused on determining how residual stress can be minimized in DMLS by applying ANSYS software. ANSYS is the integrated software platform that enables product engineers to create and simulate complex mechanical design. The purpose of using ANSYS will be to help build a CAS model. Consistently, the reaction of the several different models for the different materials and settings is achieved to determine if there is any relationship between this factor and how well its model optimize the design. On the other hand, in most occasions, it's observed that general residual stress distribution with vertical Z orientation is indicated in wide range of the parameter. The magnitude of the established stress varies with XY plane distribution with a deliverable as indicated in diagram. Consequently, the residual stress intensity is predominantly high along the longitudinal direction. The picture indicates the direction with respect to the XY and Z plane. The models were used to simulate thermal fatigue testing of the part that has been manufactured with a different angle XYZ. The results of the simulations was compared to those obtained by using other methods such as finite element analysis. Results also compared with experimental tests conducted on a different type of material. The outputs from the computer software show that was significant difference between the result obtained from each method ANSYS versus finite element ANSYS. The accuracy levels of ANSYS were found to be higher than of the finite element ANSYS. There are two outcomes expected from the stress experiment: the deformation of convention and deformation redesigned model. As indicated by the graph, the deformation of redesigned model is better in terms of push after stress applied to its compared deformation of conventional model. Significant. The process of minimizing residual stress in DMLS via two-pass planning is significant since the information from the project will provide guidance in minimizing residual stress. Additionally, the cost of the manufacturing in DMLS will reduce. The two-pass planning will help achieve the primary project objective. Companies will find DMLS reliable through the two-pass planning.